Hello, everybody. How was lunch? I love Mexican food, so I was thrilled. So I'm here to talk to you about image optimization, really about media optimization, mostly about pixel-based media, but I'll touch on video and I'll touch on SVG as well. Also, I'm a little bit sick today, so thank you for bearing with me through this. But we have a lot to cover, so I'm just gonna go right into it. This is a talk about making happy little pixels. The littler, the better. So I got a lot of my inspiration for this talk from Bob Ross, who's a famous oil painter and TV show host from the 80s, if you're unfamiliar. He does incredible work. He really is my life idol. So in order to prepare for this talk, I tried to put myself into the shoes of Bob Ross. And it didn't really work out that well. This is like a literal neck beard, if you're wondering what that looks like. So here's a better version of who I am. That's my handle. I'm Una on the internet. You can find me on Dribbble, GitHub, Twitter. Like you were just told, I'm a senior UI engineer at DigitalOcean, which means that I work on interfaces. And I'm really involved in various communities. But today, what I want to talk to you about is something that affects all of us on the web, which is images. Images on the web. We all see images, we all deal with images, and most of us have images in our applications, in our websites, things that we are building for other people. And that's why I think that this is a really important talk for you all to hear. It's really going to be a journey, and I'm going to cover a lot of topics, from technical implementations to design considerations. So there's going to be a little bit of knowledge here for everyone. We're going to start with the problem, so understanding why images are now such a big problem on the web, why they're so crufty and big, and why we're sending these to our users. We're then going to talk about the medium of images themselves. What's coming next? We're going to talk about existing image formats and future image formats. We're going to spend a lot of time talking about solutions. So everything from automatic optimizers to manual solutions, things that we can do in the design phase to optimize our images when we're delivering them to our clients. And then finally, we're going to go through an example to show the power of implementing some of these techniques on our websites. So we're going to use this example from a conference I spoke at. It's called Mixin, and I was able to get their images from 1.1 megabytes to 348 kilobytes by using these techniques on first load. So we're saving a lot of image size for our users when we combine these techniques. And before I start, I really do want to stress that image optimization is a team problem. And this is because performance is our user experience. It's not something that you can throw to your developers or just say is a design problem or any individual vertical within your company. It doesn't matter if you're a designer, a developer, a project manager, you're a teammate. And this is a team problem. Like, you can't just do this. I stole this gift from Brad Frost. It's a really good one. You can't just throw the responsibility of performance over the fence to another team, and yes, that's a monitor. We need to take responsibility on every level. Yeah, that's painful to watch. So are slow websites. So if we look at the data, this is the latest run from the HTTP archive. You can see that the average website is sending 3,422 kilobytes on initial load to our users. And out of that, 1,018 are images, and then videos, 819 kilobytes. So 77% of what we're sending are media assets, and 53% of what we're sending are images. If you take a look at the content breakdown of the sizes of those things as well, you'll see that the average single JPEG is 2.6 times bigger than the average JavaScript file, and this number has gone up. So while people are arguing about whether to include jQuery or not, remove one image request, or even like a quarter of an image request, and you can have all the additional scripts you want. I'm not saying to do that, but just like take a step back and look at what we're actually sending users. So first of all, how did we get here? A lot of it has to do with the technology that we have today. This is a chart of camera ownership over time. So you can see that camera ownership has increased. It's gotten cheaper to take photos, to keep data, and to share large files. And this is largely because of our cell phones. That yellow there, those are mobile phone cameras. So that has just gone up exponentially. We all have cameras with us here today. You know that phrase, the best camera is the one that you have with you? Well, now we have them with us all the time. This is where we are now. Now the cameras that we have with us take 12 megapixel photos. Does anybody here have the iPhone X? All right, a couple of you. So you have two 12-megapixel cameras on your phone. That's the dual 12-megapixel camera. So I want everyone here to do me a favor and to get your cameras out, get your phones out, hold them in your hand, put them up in the air. OK, now put it in front of your face like this, and turn on the camera and take a selfie. I love selfies. We shouldn't selfie shame. Selfies are a moment of confidence. I like having a stage to root for selfies. OK, so did everyone take a photo? You can take a photo of someone else if you don't like selfies. You can take an everyone else-y. Whatever you want to do. So an average photo taken on an iPhone 6, which is now an older iPhone, is 2.6 megabytes. That's twice the initial recommended load of a page for a user for the first render of a website, which is 1 megabyte. But there are about 500 attendees here today, so we've just introduced 1.3 gigabytes of photos into the world? And that's only if you took one photo. Who here took more than one? Yeah, OK, I see you. So we're at this phase where we can just take images without thinking about the consequences. It's irresponsible imaging. We can take a series of photos without thinking about the cost of it, and it turns into petabytes of data. It really adds up. And it becomes a problem when we send this to our users. This is what we're doing to people with irresponsible imaging. And more importantly, this is what we're doing to people. So what? Devices are getting better, network speeds are improving, and the classic, it works on my system, right? So last year, for the first time ever, mobile and tablet usage has eclipsed desktop usage. This is our reality now. People are using the web on their mobile devices at a much higher rate than they're using their desktops. And this is from last year. This number has increased since then. So Google did a study from September of 2016 where they surveyed over 10,000 mobile websites on 3G. And I want to play a game. It involves me asking you questions and you yelling out answers, so just prepare yourselves for that. OK, so first fact from the survey. The average load time for mobile sites is how many seconds over 3G? 10? 7? 30? 19 seconds is the correct answer. 19 seconds, that's the average load time for mobile sites. We've all experienced this. It's horrendous. Mobile sites that loaded within 5 seconds versus the average of 19 were observed to have what % longer average sessions? 30, 10, 60. It's 70%. So 70% longer average sessions if it loads within 5 seconds. What % of visits to mobile sites are abandoned after 3 seconds? So we didn't get to 19. We didn't even get to 5. We're at 3 seconds, and we're just done waiting for this website to load. 92%.
40.
We don't have any patience anymore. OK, 40. The answer is 53%. So over half of visits to mobile sites are abandoned after 3 seconds. People don't have patience for this anymore. This is what we're doing to people. So I looked into some numbers, and if you've ever heard this term, the next billion internet users, it really describes a term that shows how India and Nigeria and other countries that aren't as developed as the US, for example, are really joining the web. It's really true. It's very descriptive of what's happening with internet users around the world. If you look at Nigeria here, they have far more internet users than the UK, but we rarely see Nigerian speakers at conferences, and we see people from the UK writing blog posts, speaking on stages all the time. Why aren't we getting these points of view across? It's all the same internet. That is what makes the internet great. It's a communication device that we can all share. India is the second largest online market, ranked only behind China and the United States, and it almost has double the users of the US. And this number has grown really, really quickly. Just 3 years ago, it was ranked behind the US. And that trend is continuing to grow. It's not going anywhere. But when you look at that and compare it to these facts, you can see that in the US, 88.5% of people are already using the web. It's still growing steadily. There are some people that aren't using the web yet, but compare that to a country like India, only 34.8% of the country is online. That's a huge market potential as this number grows exponentially. This is the future of the web. when we take this and then look at web speeds, it's an even more stark picture. So here's an example of the average connection in the US, which is 12.6 megabits per second. Average peak is 57.3. A country like Australia has really poor internet, struggle there to get good Wi-Fi. Their average connection speed is 7.8 megabits per second, and their average peak is 41.9. But then compare that to India. It's 2.5 megabits per second. Their average peak connection is 18.7. And this country has more than double the users that we do. So we have to be considering that most of the people that are on the web don't have the experiences that we do. They don't have iPhone X's. They don't have really fast devices and really good Wi-Fi speeds. By not paying attention to performance, we're restricting access to information for people who don't have the connections that we're so used to and that we're building on. Performance is not an enhancement, it is your user experience. It's a core part of your product. So I really like this idea that access to information should be a basic human right, or as Bob Ross says, you can have anything you want in the world once you help everyone around you get what they want. Visionary. So my friend Sare is a London-based web developer who recently went on holiday to Iran, where she was trying to work while visiting her family and found that she couldn't even log in to Slack or to GitHub because of the authentication timeout. So when she was trying to log into 2FA, it timed out. You can't even do work. That's something that we need to think about. Like, we can't make these timeouts so quick that people aren't able to log in at all. And she also found images to be a really big problem. She was frustrated about how many sites still load high-quality images for small devices. So that's why I think it's really important to think about images and media when we are thinking about our user experience. And you can't be a web performance expert without being an image expert. So let's talk about those image formats and types. This is the understanding your canvas section of this. There are a lot of image formats. When I was researching for this talk, I found over 70 different image formats. These are 23. Please don't try to read all the words on the slide. And the thing is, every platform uses a different image format inherently. So emoji, just take emoji alone. On Mac, the format for an emoji is called SBIX, which is an extended BMP. It's just BMP on Android devices, and then on Windows, it's color.colr, which is a layered vector file. So no one can really agree on what to use for the same exact visual. Like, different devices, different platforms are not in agreement on this. But let's take a look at some of my artwork. These are my happy little trees. So we all probably realize that different images are better suited for different format types. But why is that? It's because these different format types compress and store data in very different ways. Each has its own pros and cons, and it's really important to understand these. So for example, here, images with large blocks of color and similar colors, they work a lot better when they're something like a PNG, GIF, or an SVG rather than a JPEG. Whereas a JPEG is better in this case, where you have a lot of gradation, a lot of tonality changes in your images. And so I want to briefly talk about these formats and then introduce a new one. So we'll talk about the GIF, we'll talk about the PNG, we'll talk about the JPEG, we'll talk about WEBP, which I'm really excited about, and then we'll talk about the FLIF. The FLIF. So the first one is the GIF. The GIF provides 256 colors in addition to the raw image data that is stored and displayed at any time. It doesn't allow for transparency support, but it does allow for dithering. Dithering is an added noise to reduce distortion, and it kind of looks like this. You see like these colors intermingling with each other. And there's actually two different types of dithering. There's a noise dither, which is the first type, which tends to be a little bit bigger than the second type of dithering. This image is about 77 kilobytes. But the next type of dither, which is the pattern dither, is about 67. So the type of dithering that you save your images at, if they're GIFs, can affect your image size. This one, I think is pretty cool because it's all very linear. And you can see it there. It kind of reminds me of cross-stitching, so I like it. So after the GIF, the next format that I want to talk about is the PNG. The PNG was this open source reaction to the GIF threatening to license. But the PNG was an improvement on the GIF. So it does come in 8 bits, but it also comes in true color, which is 24 bits. Because of the better compression of a PNG, it's generally better to use one over a GIF if it's a comparable image. It also allows for alpha transparency, which is pretty great. We see this a lot on the web today. A PNG is an example of lossless compression, which means that it doesn't lose quality. It uses delta compression, which means that it looks for the differences between pixels. So like I said earlier, if you have like these large planes of similar colors, like a sky, if those two color values are the same color, it can store that as a 0, which means a smaller size that it's storing. It's compressing those. Whereas if you have a lot of different color variants and gradation, it can't do that. So what a JPEG does is it looks at all the differences between all the pixels, and it discards the excess data. It rounds where it can, and it saves a smaller image by getting rid of some of the image data. So I created like a little illustration of the differences here. So lossless formats like the PNG will look at a string like this and will compress it. So if we have 10 A's, it would be A10. In this case, it's A3, B2, J, K, whatever. You can see the difference here. And then with the JPEG, it's just going to be looking at all that, running through a set of algorithms to determine what it can just toss out. So it really depends on the image for what you're going to have a smaller file size of. Normally, photos are better as JPEGs, whereas smaller icons are better as SVGs, usually, or GIFs or PNGs, depending. Testing things. That's what you should be doing, testing. A thing that you should note is that every time you resave a lossy image, like a JPEG, even at 100% quality, you will be losing detail. So if it was saved at 80% before and then you resave it at 100, you're losing quality on that resave. And it's because it's going to go through this process every time. So JPEG is really smart. It goes through this like several-step process for compression. First, it breaks down the RGB values into black and white, which is that Y, red chroma, red-green, and blue chroma channels, which is blue-yellow. It then goes through this discrete cosine transfer to create 64 coefficients within an 8-pixel grid. And then it reads this quantization table. So the quantization table is what you are setting as the level of quality you want to save the JPEG as. So it uses that table, it's a lookup table, to do a zigzag scan of that JPEG image, resaves it, goes through some more algorithms, and then you end up with a brand new image that is much smaller, saving space on your server. So lossy isn't a bad thing per se, but it is going to go through a process like this every time. And the exciting thing about this is we're still continuing to build on JPEGs. We're still continuing to build on this process. So Google recently released Getsly, which is a new open source algorithm that kind of changes the way that JPEG compresses. So instead of a quantization table that you are all predetermining, it's going to take every 8x8 pixel block and set its own quantization for that block. So it says that it incorporates the concept of cells in the retina, this AI, to make decisions in quantization instead of just that predetermined table. The trade-off here is that images take a lot longer to compress, and the results are kind of unreliable because it is changing what it is using as a baseline every single 8x8 pixel square. So while it claims to have 30% reduction in images, there was a study done by Eric Protips from Cloudinary that looked more closely into this. He compared a few examples and saw that Getsly did save images a bit more sharply and at smaller sizes than auto compression. But when you compare it to what like Cloudinary's quality auto setting, it wasn't really that much of a difference in savings. When we look at quality, you can see that it really makes a big difference for your image sizes. At a smaller size here, like you probably can't really see the difference between these mountain pictures, but the image sizes are much different. You can see the differences in the histograms. So in the higher quality, the 100%, all the colors between the histograms are preserved. In the 10%, you see these spikes, because what we're doing is we're losing the in-between colors, and it causes sort of banding and distortion in your images. If we zoom in, you can see this banding and distortion on the mountain on the right at the 10%. So like up close, it doesn't look great, and you really shouldn't try to save JPEGs for images that have a lot of sharp lines, especially like text. If you ever looked up text that was saved as a JPEG, it's just super blocky, not a good look. But yeah, this is what happens when you try to merge those pixels around them. So I like to say that 80 is probably a good medium as a max. It really depends on your image. If they're smaller icons, definitely save them smaller. If it's a bigger image, you probably don't need 100%. Just look at your trade-offs between your savings and what you're providing. So I also heard these names popping up as I was doing research on JPEG, JPEG 2000 and JPEG XR, and these are both improvements on standard JPEGs. But the problem is, again, nobody can really agree on a better implementation than we currently have. So according to jpeg.org, there's the JPEG. There is the JPEG XT, the JPEG LS, the JPEG 2000, the JPEG XR, the JBIG, the JPEG XS. So while people are complaining there's a lot of JavaScript frameworks, there's a lot of JPEGs. And really the only big difference between these is support. Like the JPEG XR here is supported by Safari mostly, and then the XR, the 2000 is supported by Safari, the XR is supported by Microsoft, so IE and Edge support this. So basically, if you're on IE and Edge, like send a JPEG XR. If you're on Safari, send a JPEG 2000. If you're on Chrome, just send WebP. Welcome to the web in 2017. This is a mess. But WebP is really cool. WebP, I think, may be the most promising new image format that is coming out. It's already out. It's pretty well supported right now. And it was initially developed by a company called Onto that Google purchased, Google Initiative now. And they've put a lot of work into this since 2010. So WebP is lossy or lossless. You can have animation support. And it does have really great compression. So it's comparable and faster than PNG and JPEGs. Like these are very different formats, but WebP is comparable to both. So I compared it to JPEG and found that it did have a solid amount of savings. So there was an average of 30% savings in lossless mode, which isn't bad because you're not losing quality like a JPEG. And you could save it at lossy mode and save even more if you want to. But I think that these numbers alone are really exciting. So the way that WebP works is through predictive coding. Predictive coding uses values in neighboring blocks of pixels to predict the values in a block, and then only encodes the differences. It's inspired by movies, the WebM, which we'll talk about later. So if you look at the support table, it's literally the opposite of the JPEG support tables. However, Safari and Firefox are experimenting with WebP right now. It says that in the notes, so that's a really big sign, considering that nobody really agrees on anything when it comes to image formats today. Also, it is pretty rated up there on Edge user voice, so if you want this in Edge, please upvote it. WebP image format support, just check this. It's at 6,233 votes today, so yay, WebP. If you want to convert to WebP, there are a variety of ways to do it. Here's a whole list. There's a WebP image format Photoshop plugin. I personally like using a command line interface. The ImageMagick CLI is a really good tool for me because it's super fast. You just type a couple of lines of code into your terminal, and it's just a script that runs and can convert everything. The problem with WebP is that there still isn't native support for it in programs like Photoshop or any kind of image editing locally. So it's kind of something that you have to save your original files and then convert to WebP either server-side or convert it through your dev tools. But that's something that you can't really use the source file. If you want to use the ImageMagick CLI, all you have to do is first install Homebrew, then brew install ImageMagick, and then brew install WebP. Once you've done that, just type those few characters in. You can type these few characters in and say Mogrify. That's the function. Change the format to WebP of all like the JPEGs, star.jpg. So you can just do this with a few characters, which I think is kind of cool. There is a WebP polyfill, but it doesn't really make sense for me to require JavaScript for everyone on Safari, Edge, and Firefox to access your content. So you can do one better and use the picture element. The picture element is wonderful HTML magic that we can use instead, and you can use it today. If you want to use the picture element, we can just send a few different sources. So you can send the WebP source first. If it's supported, it'll show. If not, then you can send your JPEG, and your user will see the JPEG as a backup. So like I mentioned, it's pretty well supported. There is a polyfill if you need to support IE 11 and below. It's called Picture Fill. It's only 8 kilobytes big, so definitely worth it to use the picture element to send these files. And I've noticed that a lot more websites are using WebP in these sorts of formats as I'm going online and saving images down. So it's exciting to see that this adoption is really ramping up. I hope to see other browsers supporting this soon. So speaking of WebM is really what inspired that, and this is for movies. It really makes a massive impact. So I just want to compare these two videos. The MP4 is 3.5 megabytes, and the WebM is 1.3 megabytes. That's less than half of its size. So WebM is something that you should definitely be converting your video to if you're sending video to users. The support for that is a little bit better, but even better than that is that to use multiple sources in video, we don't even need a polyfill. With the video element, you can send multiple sources. So you can send your MP4 and your WebM and have them as different video options for your user's browser to use. So more options, more power. I just want to mention one experimental format called FLIF. And I think it's really exciting. It's super new. But yeah, it's really cool to just see what people are working on these days, the different tech that's coming out. And also, this is the pattern, the noise diffusion pattern, not the noise. So it's like once you see it, you can't unsee it. It's like cross stitch. So the FLIF. The FLIF claims to be 14% smaller than lossless WebP, 33% smaller than brute force crushed PNG files. It has all these different claims, 43% smaller than typical PNG files. And on their website, they do also have a study of images where they compare FLIF to other formats. So here, the red and brown are the FLIF format, and that's being compared to PNGs in green and JPEG 2000s in blue. And the compression is smaller, and this is on different compression ratios also. So there is a curve there. But the coolest thing about FLIF to me is its implications for responsive images. So a FLIF image can be loaded in different variations from the same source file. This means that a browser can start downloading at the beginning of that file immediately, even before it knows exactly how much detail is going to be rendered, and then it can make adjustments. So you don't have to send multiple sources like you do with a picture element. You could just send one FLIF file with multiple encodings and then have it represented while the browser decides, OK, this is what I want for the detail. The polyfill, there is a polyfill, and its status is mostly stable, but needs more testing, which is exciting because the last time I gave this talk, the polyfill status was beta, not tested in all browsers, performance and size still being optimized. So there is active work being done on FLIF, and it's made a really big impact in the past few weeks even for the format itself. So watch out for FLIF. It may or may not be the next image format. I think it's just kind of cool to note. So I know that's a lot of things, but as developers, we're kind of used to that, especially design development landscape in 2017 is a variety. It's a jungle. It's definitely a jungle. But I think it's good because the best thing will sort of win out. And if we have multiple brains on these problems that we're trying to solve for people, we will find great solutions. So let's talk about what we should definitely be doing right now to improve image sizes, media sizes for our users. This is the solutions and pro tips. The first thing I want to talk about is automation. Everyone loves automating. Just write once and forget about it. ImageMagick, I kind of mentioned earlier, is magical for this. There's a few different ways to use it. You can use it in Webpack with your setup, with your dev setup. You can use it in Gulp if you have your Gulp as your environment setup. Grunt, you can just run npm scripts. So if you have Node that's running your system, you can just write an npm script. So if you wanted to do that, you can just have your input files. This is literally doing nothing, example of doing nothing, because we have the quality saved at 100, but we're just renaming our file from after to before. It's an example of how Node ImageMagick, like these other tools, allow for you to control a lot of different options. And you have that control. You can write it once and then have a preset for all your images to go into your source file. They'll be distributed in your dist file or folder, however you're sending it out. And you can just forget about it. So you can use ImageMagick to create your own customizations and then send them out. You can convert this to WebP, do whatever you want. I think that's what I really like scripts for, because it really is a customized control that you have. So the next thing I want to talk about is semi-automation. You have to have a little bit of impact here, but the tools are doing most of the work for you. And there's 3 tools that I want to mention. The first is Image Alpha. This allows you to pull in images, like this example of a JPEG. You can also pull in GIFs or PNGs, set the different background colors, change the amount of colors that you're sending out, and visually see the differences. So it does have a little bit of user manual input in there. You can use this in concert with something like Image Optim. Image Optim is actual magic. I don't know who made this, but I want to give them all hugs. Image Optim is such a great tool. It is a visual GUI that you can just pull in a folder of images, plop them in here, and watch the image sizes trickle down. And it can really, really, really make a big impact. So I want, if you leave this talk with anything, Leave it with this: image optim always and often, your image folder. IOAO. Let's make it happen. So someone tweeted at me a little while ago that they did this, that they just put their folder of images through Image Optim, and they saved 41.5 megabytes out of 41.6 megabytes. 99.6%. I don't know what they were doing, but it's pretty crazy. So Image Optim, always and often. The last tool that I want to mention is SVG OMG. This lets you pull your SVG images into your, in this case, a web browser. You can just pull them that way, upload them. There's a few different settings that you can apply to those images, and then you can output them and save them. So you have a lot of control over these customizations that really help get those SVG files much smaller in size. SVGs work a lot different than pixelized images, so I'm not really talking about them much in this talk, but we're going to hear more about them from Chris later. So SVG OMG is that tool, and it's online. You can go check that out. So now I want to talk about some manual optimizations that you can do, and this is where designing for performance really comes into play. So this is where you can have that impact from the beginning. And what I'm talking about is like when you design a website, oftentimes we have this large area here in yellow. This is like a buzzkill to page performance, but we can make it better. So what's the difference between these two images? They're the same exact size, but one of them is almost half the size of the other. Does anyone see the difference? If I hover them, can you see a little bit? So in the smaller one, in the 264 kilobyte image, that bottom part is blurred out slightly compared to the other one, which is in more sharp focus. It makes a really big impact there. If you blur out unimportant parts of your images, you can reduce your file size greatly, and that's because if we think about how those JPEGs are compressing, if you see fewer difference between those pixels, it doesn't have to work as hard to save all of those bits as individual files, so it can throw out more data. So that's why if you just do a little bit of blur on the sides, you can really reduce your image sizes. So Medium Renders uses sort of like this blur up technique on their articles, where they take their images and use them as placeholders, sort of scaled up and blurred out as a preview until their image animates in. So we can do this too. If we start with this image, it's 409 kilobytes, we can save it as 30 pixels big. So if we save it as 30 pixels wide, it is now 0.533 kilobytes big, less than 1 kilobyte. We've saved so much image data. Then we could scale it up to fit its container and use something like a CSS filter, like blur. So then, while we're waiting for our image to load in, we just have blur and then appear in. So this is really good for perceived performance as well, because we have a gist of what we're expecting as a user when we land on this page. And we're not sending them these massive images they have to wait for to load. It's just a little touch of what's coming, and then they get the image once it's loaded in. So you can wait for all the rest of your content on your page to load, get your actual text data, get your scripts, and then have the images load in while you have this placeholder in place. So because of how Facebook gets its image data from their GraphQL databases, if they send a file that's less than 200 bytes big, they can avoid an extra image request. So they use this technique as well in their cover photos on mobile, which saves time and data for users. It's called Blur Up if you want to look it up. There's a lot of different articles on the web with resources and plugins on how to help you set this up depending on your configuration and on your dev environment. It's also similar to placeholder images. So with placeholder images, you could send a small image, like a data URI, and then use a data attribute to hook in an image on load and have that be replaced. I also recently saw someone using SVG for this, where they resave those images as like duotone SVGs, and then wait for the photo to load in, which is really cool itself also. So a lot of different solutions for this. But the pro tip here is to embrace the blur in your images. Blur can be a great thing. Okay, what's the difference here? Just kidding, it's obvious. Unless you're colorblind, sorry, I shouldn't have said that. So the one that's smaller at 730 kilobytes just has all of its color data stripped out. It's saved as a grayscale image, and it saves almost 200 kilobytes in data size. Black and white does save us a lot in image size, but it doesn't have to be boring. Hello, blend modes. CSS Blend Modes can make black and white images fun. So I do want to have a moment to talk to you about blend modes, have a brief sort of overview on them to show you how powerful they are, because they're still really underutilized on the web. They can really bring a lot more color, uniformity, and art to the web. So I want to at least introduce them to you to do a little primer on the blend modes and how they work. The first one is multiply. I have this hot pink color on top of this black and white image. So multiply uses the luminosity values, those black and white values of the image, and or of the color layer, and it multiplies them with the image behind it. So it's like if you have a transparency and you put two transparencies on top of each other, if you have something that's just white, it'll shine through. But if it's dark, it'll either multiply those dark colors or it'll override. So that's kind of how multiply works. It uses the luminosity values. So screen is sort of the total opposite of that. Screen is like multiplying the light value. So you're taking the inverse of everything that we just did for multiply, the inverse of the active layer's luminosity, the inverse of the background layer's luminosity, multiplying those, and then taking the inverse of that. And the way that you take inverse in these kind of calculations for blend modes is by subtracting those values from 1. So multiply and screen are a little bit different than darken and lighten, because darken and lighten look at each of the RGB values, and they end up creating new tones, new tonalities based on those values. So if we compare RGB 10, 250 to 150, 100, and 150, we're going to be looking for the darker value of that. So if black is 000, what's darker, 10 or 150? It's 10. What's darker, 200 or 100? It's 100. What's darker, 50 or 150? It's 50. So we create this new color value based on those color tones in the image, in those two colors. That's just an example. And then with lighten, we're looking for the opposite of that. We're looking at the lighter color of those two when you're comparing them. So the next one is difference. Difference takes the absolute value of the difference between the luminosity of the active layer minus the background layer. And similar values here turn black. This is similar to exclusion, but with exclusion, similar values turn a 50% gray, so it's much more muted. There are also very saturated blend modes like color burn. Color dodge is also very saturated when you're applying it. And then there's blend modes that combine multiple other blend modes. So as an example, soft light combines screen and multiply. It uses screen on the light values of 50% and multiply on the darker values of 50%. The hard light blend mode uses color dodge and color burn on light and dark values. And then overlay also uses screen and multiply, but it's not as muted as soft light because the midtones are transparent, so you don't have like that soft muted value. I think that blend modes are also really exciting to use when combined with CSS gradients, because with gradients, you can apply multiple colors on a single plane. So here's where we can really start getting creative with the web to start playing with different blend modes and seeing how they affect our images. So here I have the color blend mode. With color, what we're doing is we're taking the saturation and the hue of that color value and applying it to the image behind it. Now, if your browser does not support blend modes, it's going to look like this if you have that blend mode on top of your image. So in order to avoid this and use blend modes and these colorizations as a progressive enhancement, we can always make sure that our image, our black and white image at least, is on top of that blend mode. So what we're doing here is we're setting that blend mode to the index of -1, so it's behind the image. And then we can apply the blend on the image itself. So now I'm applying a mixed blend mode of luminosity to this image. And what that means is going to take only the luminosity value, which is the black and white, and blend that with the color behind it, which is the hue and the saturation. So it's doing the exact opposite, but on top of it. So if you want to use blend modes and you want to make sure that your user is still seeing an image that is important to your data, to your content, you can just do this technique. If they don't have blend mode support, then they will see a black and white image. But you can also send this based on browser support if you do testing. So speaking of support, there are two different ways to use blend modes. They're decently well supported on all major browsers except for Edge and IE. So there's two different ways to use blend modes. There's mixed blend mode, which allows you to mix different elements behind others to blend those. And there's also background blend mode, which allows you to blend within an element itself if you have multiple backgrounds. So two different ways to use those. Now, blend modes do have some cost to your web page rendering because they have to take a moment to repaint the page. This is a site called CSS Triggers. It's a really good tool to see how different CSS properties affect loading of your page, and especially as you change those properties. So I wanted to sort of benchmark how that rendering, how that additional time sort of affected the savings that we were getting from the image. Like, was that rendering time bigger than the size savings? So I wanted to sort of like do a little test of this. I'm warning you that this is just a small sample size. But I compared the image savings that we're getting in those files. So what I did was I sent the image as a full color, as a black and white, and then as the black and white with the blend mode. I looked at the results. So consistently, I found that the full color loaded slowest. It loaded about 0.3 seconds slower than the black and white with the blend mode. And then, of course, the fastest one was just the image, the black and white image. So I found that it loaded at about 0.3 seconds faster to send the black and white image with the blend mode applied than to send a full color image. But that's not really like a perfect study. So I wanted to then do this with images alone, pre-edit that image in Photoshop to give it that pink overlay, and benchmark that again. So this time we're getting 115 kilobytes of savings, not 190, because a little bit bigger, we're sending some color data with the image. So I did the same thing where I sent the black and white image compared to the pre-edited pink image, and found that, again, it still saved a lot of time and memory in Photoshop. So I recently saw this too on Photoshop, in Facebook. They do the same thing where they send like a black and white pixelated image and then apply color. Like if you blink, you'll miss it. But I thought that that was really interesting. Like they do the same thing there. So pro tip, less colors, less problems. I also really quickly want to mention a study that I did recently. I wrote a blog post for CSS Tricks where I dove into this idea of reducing contrast to also reduce color space, which reduces your image size. I call this the contrast swap technique. So what you can do is start with your image, and then you can remove your image contrast. I opened Photoshop and I used legacy mode because it gave you a linear transformation for reducing that image contrast. And then I reapplied that contrast using CSS filters in the browser. So what you're sending is this de-contrasted image, and you're reapplying that contrast when your user is in their browser. So you are saving a lot in image size. These are some of my studies. So here, the first one, it saves almost a full megabyte of data to send the desaturated image with a, decontrasted image with contrast applied with filters. The second one saved about half a megabyte. Then this one saved 0.8 megabytes. I found an average savings of 23 to 28% image savings by doing this technique. And I did profile again. When we go back to that painting question, I actually profiled this at a 6 times CPU slowdown and found that it was a really negligible change. With a 6 times CPU slowdown, the longest individual rasterized paint took 0.27 milliseconds, which is 0.00027 seconds. So totally viable technique. I also tried to re-add the contrast in Photoshop to see if just reducing it that one time, re-adding it, actually affected the image. And when I added it back, it did put back the image size onto the actual image itself. So reducing that color space is what made the difference here. I love this quote from Bruce Lawson: "If you have to send a loading indicator, you're not optimizing your images enough." Because there's so much that we can do. There's so many things that we can do from design to development through the entire process to make our images and media smaller. So I want to really briefly talk about animated images. And the first example I'm going to give is this GIF. So I was working on the redesign of DigitalOcean.com, and we really wanted to get our website below 1 megabyte on initial load. And this GIF here, after automatic optimizers, it looks like this right here, was still bigger than 600 kilobytes. So I ended up getting it 200 kilobytes smaller, which is an over 30% smaller savings, by opening it in Photoshop and actually looking at all the different frames here. So you can do this. There's an animation sort of toolbar at the bottom. You can open that up, and a lot of these frames are similar. So if you remove some of those, make some of them last longer, you're actually reducing some of the frames of your GIF, which can make it smaller. At the same time, I also reduced some of the color space, and these two things combined allowed us to get that image smaller than that we needed to make that page load initially less than 1 megabyte. So it reminded me of my desk animation shop days when I used to open that up and like do pixel by pixel animations. It was good. So a pro tip here is to format the frames. You can do that. You can open this even in preview and see all the different frames of your GIFs. So there are a few GIF alternatives that have come out over the past few years, but none of them have really caught on yet, which is frustrating because GIFs are so big. The one thing that was most interesting to me, though, that is kind of like a GIF alternative, is this thing called GIF-V by Imager. So GIF-V automatically converts uploaded GIF files into either a WebM or MP4 video formats, depending on browser support, and preserves that GIF-V extension. So that really decreases the file size. Since you're not sending GIFs, you're sending videos. Videos are much smaller than GIFs. And in addition to that, silent video autoplay is back on mobile. This was removed from mobile until iOS 10, but now if you have silent videos on your mobile devices, they will autoplay. So like if you have a background video, which I'm not saying to do, it can now autoplay, which it couldn't do before. So I think this is exciting news for GIFs specifically, because it means that we can get rid of the need for massive GIFs on mobile, where it's really a bad idea to send GIFs, and use auto-playing videos instead. So why are GIFs so much bigger than videos? GIFs store every frame. So there's no lookups or preloading. It just shows a picture, and you get all that. But the video will store the differences between frames. So it's like a formula, and it renders at speed. And fun fact, in a video, if you have more movement, it becomes a bigger video file because there's more movement between the frames that it has to render. So it's inter-frame compression versus inter-frame compression. And inter-frame is much, much smaller. And that's where you get this inspiration for a lot of the WebP image format that we're seeing. It's from this image-inspired video codecs. So before we get into our wrap-up example, I want to quickly talk about server-side image optimization because it's very powerful. And I just want to mention 3 things that we should be doing to improve our media performance here. The first thing we can do is to leverage cache to keep our media alive. In this example, we're setting our HT access to preserve images for a year, and also our CSS, HTML, and JavaScript for a month because they're more likely to change at a quicker rate and don't need to be saved for as long. So if you're caching things, you'll definitely be improving your user experience on their second load of your app or website. Another thing that we can do is to predetermine the optimal image format and send that to the user to load as soon as they land on the page. So remember all that talk about choosing the best image format? We can do that once the user lands on our page. We can make that decision from the server side and then send it to our users. This is an example of sending WebP to our users. And if we want to see what that looks like as an Nginx config, you have the slides, but basically we have a couple of steps to do. First, we have to determine a consistent naming scheme and a location. So if we have something called unicorn.png, we want to save our WebPs as unicorn.png.webp, for example. And then we want to write a script to read the browser headers, looking for an HTTP accept header for WebP specifically, or whatever format you choose. And then we want to make sure to serve original files if there's no WebP counterpart. So we want to send a backup. Always send a backup for your users if you can't access that WebP file. OK, so building off that last example, with a few lines of code, we can also allow for gzip of our assets inside of the HTTP object. So this is really important for text-based assets, specifically for SVGs when we're talking about images, because they can really reduce the size of our text-based files. It can take one big text file and just kind of save pieces that are repetitive and decrease that file size. So with these 3 sort of server configurations, there are a lot of different ways to do each of them, and it really depends on your personal configuration. But I would just look up those 3 things or talk to the DevOps team to look into them. But it can make a really, really big impact for your users. So all right, quickly, we will do a overview kind of paint to see how we can reduce images. So I brought this up at the beginning of the talk, this website. And I want to kind of go through how we can just do some sweeping changes to make the images smaller on initial load. So step 1 is to determine the greatest common denominator image size. This is like the lazy way to do this, to cut these images. So GCD is a term I remember from middle school math, but we're looking for sort of the biggest place that image is used on the site. So let's do this. I was looking at the speaker photos initially to start, and I noticed that this image is 540 pixels on the screen, but we're setting it at 1560 pixels. So if this image is being reused throughout the site, I wanted to see all the different areas that it was being used. So it's still 540 there. OK, here I found it's a little bit bigger. It's at 661. So now that's currently the biggest size. And then, bam, I found it here at 780. So that means that we can reduce this in half. We can scale down all these images by half because that's the biggest potential size that we saw it on the site to fit into their containers, to natural size their containers. So you can do this with Photoshop. You can do a Photoshop battery size. You can do it with ImageMagick CLI. If you do it with ImageMagick, which I like to do, you can just use the Mogrify function, enter that folder, and resize it 50%. So this is just sort of that lazy way to make improvements overall. But you might be thinking, like 50% doesn't seem like a random number. And you're right. They didn't pick this number out of anywhere. The people who built that site, they're smart people. They did it because they heard this idea. Save Retina images at 2 times their size. This is the advice that we hear, but I kind of want to challenge this because of its performance implications and because it doesn't often really make a big difference. So if we look here at these 2 images, you can't really tell which one is Retina size and which one isn't. If you can't tell on your devices, if you're looking at this in your laptops, your Retina laptops, and your users definitely aren't going to be able to tell. The only real difference is in that image size. Another thing is, it doesn't really make a difference if you have like these 2 times bigger images if you don't have super high quality photography to start with. So if you have the average just image on the web, it's going to not make a difference. So here we have sort of divided in half to that GCD image size. But if we reduce this to the largest size that it is on its container, we get even more of an improvement in image size. We can send it at 60 kilobytes instead of at 117, which is about half. That's a 195% improvement in image sizes. And it's just from that one image, we've saved over half by reducing it alone. Now, if you really want to send high-res images, you can use SourceSet with the picture element to detect pixel device aspect ratios, but don't send it by default. That's just rude. Don't do that. There are other areas that can be improved too, especially with smaller images. This is where you really want to reduce that image size, but also you want to save it at smaller qualities, because as we saw earlier, with these icons especially, you're not going to see a big difference if it's 80% or 10%. So just from saving the speaker images to the max size that they are shown on that browser, we've saved 0.6 megabytes on the initial download for your user of that site. That's a 220% savings in render speed and memory. So you're literally saving your users money by doing this. Step 2 is to consider the image format. This is where we can also get a lot of really great image savings. So if we convert these JPEGs to WEBP, even with the picture fill polyfill, which is 8 kilobytes, we're now at 348 kilobytes. So now we're at a 316% savings in image sizes, just on the homepage and initial load. So once we've done that, we can think about responsive images. And these you can't even measure because you don't even know what device you're going to be sending things on and what kind of savings you're going to be providing for your users. Use smaller quality on smaller, less important images served at smaller sizes. Don't send the massive Retina images to all devices. It does make a massive impact. And you can do that in one of 2 ways. There's actually a lot of ways. What AEA is doing is using media queries to send different images at different sizes. So that's a good idea. That's a start. And this is definitely effective. And another thing that you can do is use picture. So you can use picture and media and source set attributes to send different images at different sizes that'll load on your page based on the parameters of your browser. So again, responsive images are something that we should all be leveraging. It's a responsible thing to do for our users. Finally, remember to leverage that server configuration if you have access to it. So cache your images, turn on GSIP compression, and send the proper image format to your user. A few months ago, I was at a conference in South Africa, and I got some really interesting insights about internet usage from a lot of the attendees. So when the people in South Africa visit international sites, it's a really painful experience for them, especially when you have these moving images in the background and all that stuff. A lot of people even called those sites unusable. And one woman I talked to, Lee Peterson, said this quote, "If it doesn't work offline, it won't catch on." And I thought, like, okay, that's a little harsh. But then I looked more into it. And I found that sites like YouTube have caught on to this. And in 12 countries, they've always allowed for offline downloads. Here in the US, YouTube Red allows for this, so you can pay for a service that allows for offline downloads. But YouTube would not have caught on in South Africa if they couldn't have offline downloads. Also, India is on this list. India, a country with over twice as many internet users as the US. So that's something to think about. These are the people that are using the web. And performance optimization is especially important for these massive markets. So step 5 is to literally profit. You will save not only your users' memory and money, but you could be making money if you have an e-commerce site. For example, Amazon calculated that a page slowdown of just 1 second could cost it $1.6 billion in sales each year. 1 second, $1.6 billion. That's a crazy, crazy number. And even if you don't care about page speed and information access, improving your performance will still be worth it. So finally, if a lot of that in this presentation was overwhelming, you can use a CDN. Cloudinary is a really great service. It serves your images on their CDN, which is a content delivery network, so they get to your users faster. They also can do server-side detection and send the most performant images, like sending WEBP. They can resize your images for you and break them up into different sizes, serving the most optimal images to your users. So if you want to apply a lot of these things, Cloudinary is a really great tool for that. There's a few different ones out there, but you still have to design for performance. So everything that I mentioned in that manual sort of section, these are things you can do on top of all the other things, like using Cloudinary, doing all those optimizations to make sure that your users have a really great, speedy experience on your site. So what do we have to do? Probably don't send an image larger than it needs to be. Be aware of emerging image formats, their pros and cons. The picture element is your friend. Use the picture element. Compress your images to low qualities, smaller images, smaller sizes, smaller devices, especially smaller images. Always run your images through an optimizer. Image optim always and often. Small improvements are still improvements. Be aware of that. Involve your entire team. This is a really important thing to mention. It's not any vertical's responsibility to create a performant product. This is everyone's product. So make sure that everyone is aware of this from the bottom up, from the top down. And find balance. In the end, it's really all about finding balance for your user. It's really about user experience. So this is one of my favorite Bob Ross quotes. Remember how free the clouds are. They just lay around the sky all day long. He's brilliant. This is how the web should be. People shouldn't be obstructed by media to use the web. The web should be free, a place for users to ebb and flow wherever they want and access data when they want. Build happy little pixels to make happy little websites and happy users. What it all boils down to is a single principle: to build a better web. Build it to be faster and more accessible, and consider that small incremental changes can lead to a large impact overall. Build something that people love, but more importantly, build something that people don't hate. Thank you so much.